Yeah, so in this exercise, actually the first part is going to be very similar to what we did last week, because we need to calculate this BGD over little rs first, so just repeat that again. The first thing to note for the single-phase gas case is, of course, the composition we use here. So we use a GOR of 6,000, an API of 50, and then the following reservoir conditions. Okay, and the what we know when it's a single-phase gas case is that the saturation of gas is 100%, and from this we can then use the properties that's already provided in the overview right here of expansion factor and solution CGR. So the BGDI is just the inverse of expansion factor. The solution CGR is just provided, which allows us to calculate the same number we calculated last week, which is the BGDI over little rs, and that is the same as we got calculated automatically right here, so we know we've done it correct. And why does that make sense? Well, it makes sense because we know that this particular formula right here will simplify to the BGD over little rs when the saturation of gas is 100%. That's provided for us. Okay, so that's nice. And so this is a gas condensate case, but you can use these total formation volume factor and GOR exactly the same way as you would do for an oil case. So the hydrocarbon pore volume here is just 20 million barrels. The original oil in place is just the hydrocarbon pore volume divided by the formation volume factor provided and calculated here, the total one. And the original gas in place is just the GOR multiplied with the original oil in place. So it makes our life very simple. For a little bit more advanced case, we can go to a two-phase saturated case. So it's exactly the same composition. The only thing we've changed is the GOR and API is the same. The only thing we've changed is the initial reservoir pressure. Okay. So from this, we see that we now have a oil saturation and a gas saturation. And what this means, just so I can show that in maybe a plot that makes a little bit more sense, is if you plotted the phase envelope, we're actually inside of the two-phase envelope in situ. Okay, so and that's you can actually observe that many places, at least from measurements and modeling in actually quite a few basins in North America. So it's important that we actually are able to deal with that. Going back to the black oil table, we see that the fluid properties at the initial conditions are provided for both the phases right here, and that's why we need to, of course, write them up accordingly. So first of all, we need to write in the saturation of oil and gas. We need to also note down the formation volume factor for oil, the solution CGR, the BGDI is just the inverse of the expansion factor. The solution CGR is provided for us, and for the gas phase we can just calculate the BGDI over little rs with just a simple division here, and we also just multiply that with a million because the solution CGR was given in barrels per million, and then we get 13.3 for that gas phase as the I guess kind of volume factor for the gas phase. The next thing is that we will use these formulas that was provided in the link that was sent. So the total formation volume factor for oil, we will take that exact formula for these properties and calculate the total formation volume factor for oil. Okay, so the formula is just to do either 100 or 1, depending on what kind of if you're using fractions or percentage. So it's 1 over essentially the saturation of oil divided by the BO, and then the saturation of gas divided by this BGD over little rs. Okay, and that provides you with 5.68. And we can go in and just compare those numbers. Yeah, and those won't be exactly the same because we are lacking some digits on the SO right here. The other part is the total GOR. That's a little bit more of an involved function actually. It's this function right here, but the same things apply. It's just plugging in the numbers and make sure that you keep your units straight. What you can see here is that everything above here is kind of dealing with the it's in the same units, and also everything below here. So this is actually SG divided by BGD over little rs, this term right here. And this is also the same for dealing with the volume factors for the oil phase. So what we do in terms of that is somewhat of a more involved function. Above the denominator we have the SG divided by the BGD plus the solution GOR times the saturation of oil divided by BO, and then it's simply just the saturation of gas divided by the BGD over little rs, and then we have the saturation of oil divided by the BO. That provides us with 60.92 scuffs per barrel, and if we just look at that, that's fairly close to this number right here. If I actually put in the exact numbers for saturation right here, which I think is something like this, if I'm not mistaken. Yeah, I think this is the exact same. We should get something that's very similar at least. Yeah, so 60.74 and 5.66. Yeah, so that is good. We get the same as is calculated by the software. That's also a verification that we're doing things correctly. But yet again, the most important thing is that when we were calculating original oil and gas in place, we're using the exact same formula. It's hydrocarbon pore volume divided by the total formation volume factor for oil, and then we just multiply this original oil in place by the total GOR, and we have our two numbers. So in that sense, it's very, very, very simple. And just yet again, just to compare this, if you had a single phase oil case, you would, in theory, if you had those numbers, use exactly the same, formula. You would do the original oil in place divided by the formation volume factor total, and you would also just multiply the original oil in place by the GOR, where, okay, this is actually wrong, but where the total formation volume factor is the same as the BO, and the total GOR is just equal to the solution GOR in this case, where we have 100% oil saturation. Very good. So on that note, that's the last part of the preparation, and we're looking forward to having you all in the course on Wednesday and Thursday.